Happy Tuesday, grade 12s. I hope the quiz went all right. I will mark them when I get back and get them back to you as soon as possible. So hopefully, if you guys fax them back by Thursday during class, I should be able to have them marked for you. Okay, so today's kind of a long lesson, so we're going to take everything we learned from exponential logarithmic equations and apply them into real world. So now we're talking about investing money. You guys are all going to be investing money either using simple or complex interest. Now that you're in grade 12, you're almost out on your own, so this will be really beneficial to you. Or you could just use a banker and never see this again, but you'll understand what they're doing, okay? So we're going to be talking about simple and compound interest. For the rest of today, all we're going to be working on is simple interest, and then tomorrow we'll be working on compound. So we'll be splitting this lesson 7 up into the rest of today and all of tomorrow. Okay, so we're talking about simple interest today. It's usually applicable to short-term investments of 1 year or less, or to long-term investments where annual interest is paid to the investor and not reinvested. So if you invest $500, earning interest at a rate of 6% per year, how much interest would you earn in 1 year? So in 1 year, how much interest would you earn? All you have to do is go $500 times 0.06, because when we're changing percent, so at 6%, you're moving your decimal places twice to change the decimal. It would be 0.06, okay? So $500 times 0.06, 500 times 0.06, enter, 30. So you would earn $30 interest. In half a year, you would just either divide by 2 or multiply 1/2. So be 50 or 500 times 0.06 times 1/2. I know that 500 times 0.06 is equal to 30. We just did that in part 1. I know that 1/2 of 30 is 15. So I know that in half a year, I will earn $15. Okay? In 1 month. So start off regularly. So I have $500 times 0.06. 0.06 is 1 year. 12 months in 1 year. So if I have $30 in 1 year, I'm dividing by 12 or multiplying by 1/12. So if you don't know how to do this in your head, just go 500 times 0.06 times 1/12. I put 1/12 in brackets because your computer does use BEDMAS. Okay, 2.5. So you would earn $2.50 every single month. If we're dealing with money, always round to the nearest hundredth, okay? Money, we're always working in cents, so always go to the nearest hundredths in money. So if R is the annual interest rate, so this is just going in general now, expressed as a decimal, and P is the initial investment, calculate how much interest would be earned in 1 year. So in 1 year, looking at this, it'd be P times R. Okay. In half a year, it'd be P times R times 1/2. In T years, it would P times R times T. If T is number of years, you're just multiplying by the number of years. Okay? So looking back at the first one, it was 1 month. 1 month is 1/12 of a year. So that would be your T. Okay? So don't get confused like that. If it's half a year, my T is in years. So if it's half a year, my T would be 1/2. It's 1 year, my T would be 1. So this is our formula for simple interest. I equals PRT. You guys have probably seen this before. So I is the amount of interest. P is the principal or initial investment. R is the annual rate of interest expressed as a decimal. And T represents time in years. So always remember that T is in years, okay? Don't get confused there. R is always annual rate. Annual, we talked about this before. So annual means yearly. So if ever you hear the word annual, annum, dash A, it's always going to be per year. Okay? So let's just do a question here. Millie invests in $2,350 at 7% per year for 6 months. Calculate after 6 months the simple interest on Millie's investment. Okay, so let's start out with our formula. We have I equals PRT. If we're looking for the investment, we're looking for I equals, our initial investment was 2,350.00. Our R, if we have 7%, we're writing this as 0.07. And if we're going over 6 months, 6 months would be 6 over 12 months in 1 year, or you could just do it as 1/2. Okay, you could go 6 months over 12 months, or you could go, that 6 months is half a year. You could just multiply by 1/2. They're both the same thing. Okay, so in our calculator, you go 2,350 times 0.07 times, let's go 6 divided by 12. That'll be consistent with what I wrote down. Enter. 82.25. So I equals 82.25. So this is the amount of interest she earns. Okay. So now if you're looking for the value on the investment in part B, all you want to do is take your initial investment and add it to your interest. Okay, so our initial investment was 2,350 plus 82.50, or sorry, 82.25. If you want to do this in your head, go for it. But I know you guys like your calculator, so 82.25, I already have that up there, plus 2,350. Enter. So the value of Millie's investment here now is 2,432.25. 2,432.25. So that is her total. All you're doing is just taking your initial, adding the interest. We're just going to touch on compound interest just so you understand the difference between the two. So in simple interest, the principal at the beginning of the second year is the same as the principal at the beginning of the first year. So simple interest is always going to be the same principal. So in compound interest, the interest earned during the first year is added to the original principal to form a new principal. So in compound interest, you're going to have a new principal every year because since you are adding interest, you're basically going to be getting paid interest on your interest. So every time your interest goes up, you're going to make interest on that. Okay, so simple, you always start at your initial investment. Compound, you will make interest on your interest, or you'll pay interest on your interest depending if it's a loan or an investment. So to understand the comparison between simple and compound, do the investigation in the next 3 pages. We're only going to do the next page, or the next 2 pages. Oh, just wait. Compound formula. Okay, we'll just do, we'll do the next 3 pages and then we'll be done for the day. If you don't make it to these next 3 pages, just stop and then continue on tomorrow, okay? So on this page, exploring simple interest and compound interest, bank offers 2 types of savings bond. Regular savings bond, simple interest at 9% PA. So P.A means per year, per annum. Or compound savings bond, which pays interest at 9% PA, compounded annually. So consider an initial investment of $15,000 in each bond. So simple interest each year is 9% of 15,000. So let's just figure out what that is. So 9% would be 0.09 times 15,000. Enter. So 1,350. So this means that every single year I go up $1,350. Okay? So if I have my calculator, if I have 15,000 plus 1350, enter, you can see in the second or after the first year, at the end of the first year, your investment is going to be at 16,350. On this chart on the right hand side, you can see that at the end of year one, it is 16,350. If we add 1350, check your work. 17,700 on the right hand side at the end of year two, 17,700. Looks good. Add another 1350. Enter. 19,050 at the end of year three at the chart on the right hand side, 19,050. Add it again at the end of year four, 20,400 plus 1350. At the end of year five, 21,750 plus 1350. So at the end of year six, it'll be 23,100. I'm just going to write down what we're doing. Okay, so let's add 1350. Enter. 24,450. And then I'm going to add 1350 again. The last time. Plus 1350. Enter. $25,800. So at the end of the 8th year, the investment has went from $15,000 to $25,800. So it looks pretty good. Okay, so let's look at compound interest. So complete the following to determine the compound interest and value of the bond. So at the end of year one, the thing about compound interest is it just takes a little bit more time to calculate, okay? End of year one, you have 15,000, so your principal investment plus your interest. So it's always your principal plus your principal times your interest rate, okay? So if I have my principal plus principal times interest rate, I have 15,000 in both. What they did here is they factored out the 15,000 because 15,000 is common in both terms. So you can factor it out. So you can factor out 15,000 in this step right here. You're left with 15,000 times 1 plus 0.09. You can add 1 plus 0.09 in this next step. So you have 15,000 times 1.09. At the end of year two, you have 15,000 times 1.09 plus 15,000 times 1.09 times 0.09. So this is just saying at the end of year two, you're taking this right here, this investment, and you're adding on another year's worth of interest, okay? So you have a new principal interest. So this is still your principal in this box I'm making. So that's your new principal. And this right here is your interest. So there is a pattern going up here. I'm not going to keep explaining to it because not being here in person might confuse you. I'm just going to tell you the pattern. So at the end of year three, it'll be 15,000 times 1.09 cubed. So you can see that this exponent will always be the same as this year, like in year two. After year two, your interest rate was squared, okay? So let's try this next chart. The value for the bond at the end of each year is 1.09 times the value at the end of the previous year. So complete the table below. After 4 years, it's going to be 15,000 times 1.09 to exponent 4. Okay, you guys have got this. Okay, so you're going to pause this video right now So Mrs. Nichols is going to pause this, and you're going to put this into your calculators. Finish this table. When all of you are done, press play, and then I'll give you the answers, okay? So once you press play, you'll have the answers written up. Okay, so once you've checked your work, you see the bottom one has a general. So the value at the end of n years, so n is just general after a certain number of years, is going to be 15,000 times 1.09 to the n. So again, you're going to pause this because you're going to plot the data from the simple interest. You can do this, okay? So your x is going to be your number of years. So this will be your x up here. This will be your y. You're going to plot this data. So pause, plot your own, and then when everyone's done, you're going to press play, and then you're going to see if it is still, if you guys are the same, okay? So plot the data from simple, plot the data from simple interest first and then compound. So you're going to do both. I'll do simple interest in blue, and I'll do compound in green. Sorry, I have to start over. I was doing the wrong one. Okay, so it starts here. Okay, so I'm not going to plot the rest. You guys probably should get it. You can see that simple interest is going to be linear. Okay, and then I'm going to plot in green the compound interest. So in green, it's going to start off pretty similar, and then you can see the changes. Okay, so this green graph is going to be compound. So this green one looks like it goes up exponentially. Okay, so this compound interest is going to be where your exponential equations fits in with simple and compound interest. So compound is going to be exponential. And your simple, it's going to be linear. Because you go up by the same amount every year, compound, you build on your interest, okay? So we plotted simple and compound. It says don't join the points, but I did just to show you. Which one was exponential, which one was linear. So the final amount A can be written as an exponential function of the number of years n in the form A equals A times B to the n. State the values of A and B and write the function in this form. So if I have my amount, right, oh, it's actually written right here. So this blue circle up here, my A would be 1,500 or 15,000. My B would be 1.09. And then exponent would be the variable, okay? So how do the values of A and B relate to the scenario in this question? A is the initial investment. So if A is initial investment, B will be 1 plus the annual interest rate expressed as a decimal. So expressed as a decimal, that just means change your percentage to a decimal. Okay, so the next page, the difference between exponential growth and linear growth is more apparent if we extend the graph in F to more than 20 years. So you can see how much compound interest will build compared to your simple interest. Okay. So use a compound interest graph. So compound is the exponential to estimate the number of years it would take for the initial investment of $15,000 to increase in value to $50,000. So if you're looking at your graph to figure out $50,000, you're going to find $50,000. You're going to go right until you find your compound interest graph. And you're going to go down to see how many years that would take. Okay, so it's between 10 and 15, so it'd be 11, 12, 13, it'd be about 14 years. So this is really easy. All you have to do is just look at your graph and figure out the points. So let's look at $100,000. So I'm going to do this in green. At $100,000, you go right until you find your compound interest graph, connect there, go straight down between 20 and 25. 2 points in between, so it'll be 22 years. So tomorrow's lesson, you will determine how to figure this out algebraically. Okay. So consider an investment of $30,000 compounded annually at 5% per annum. Write an exponential function which will represent the final amount $8 after n years. So final amount $8, so it'll be A equals. Your little a will always be your initial investment. So if your investment is $30,000, that'll be your little a times, if I am compounded annually at 5% per year, it'll be 1 plus 5%, so it'll be 1.05. All to the exponent n. I'm saying to n years. Have an investment of $750, compounded annually at 3.5% per annum. Write this expression. So I have, again, A equals. My initial investment is $750, so that'll be my little a, times 1 plus, I have 3.5% Don't get confused here. 3.5% will be written as 0.035. So 1.035 all to the exponent n. So we have a general compound formula then. Okay, so in general, if we have A equals the final amount or the value of the bond, P equals the principal or initial investment, I is the annual interest rate, and N is the number of years, we have the formula. So our principal investment is always being multiplied to 1 plus our annual interest rate all to the exponent N. This right here is your compound interest formula. Okay, so compound interest formula, you should be able to do roughly questions 1 to 7 right now if you do have time left. If not, so we can work on them on Wednesday.